We have a facility in Houston that's all they do is impeller cores, pump housings, etc. We can do very large cores. Okay? We can also incorporate special handling features for the foundry so that they align the mold properly, align cores properly, etc. Okay. We do aerospace work, we do automotive work, we do oil and gas work, mining, off-road. All of those applications require, industrial quality, if you will. So we meet those standards. Okay. We can do very large molds. This is a 3,200 kilogram mold package for a steel casting that was for aerospace tooling. So again, these processes are being used for large industrial applications. A comment one of the gentlemen I work with at Aramco made is, these technologies aren't just for making bobbleheads anymore. That is certainly true. Yeah. We can do very complex parts. So if you're familiar at all with the foundry industry, this would have been a challenge to assemble these cores and not have a stack-up tolerance error. We're able to print that as one core. So that's real high level, the technology. Let's talk about how I see it impacting the localization in the kingdom. Prototyping. I've heard a number of speakers, both last night as well as this morning, talking about technology transfer. And while technology transfer is a needed thing to occur, product development has to continue. Once the technology is transferred, you still need to be doing product development, product innovation. The 3D printing processes out there, not just ours, all of them, are very well suited for the prototyping industry. Some better than others. We do metals, therefore we do actual usable prototypes instead of just plastic prototypes. We're able to decrease the costs of prototyping by up to 90%. We've had customers that they had projects that they really did not think that they would get budgetary approval for. Whenever they came to us and got some quotes, we were able to bring the investment down to the point where it did make commercial sense. We're also able to decrease lead times significantly. Again, there is no tooling, so for your local industries to thrive, they need to be able to be in the product development realm. I brought in some of our case studies of customers that are related to these industries. Andritz Ritz is a pump manufacturer. Some of you may be aware of them. They were in the process of trying to design some more efficient impellers, pump housings, etc. They had a number of different designs they were interested in pursuing. And in traditional manufacturing, that would not have been feasible because of all the tooling. We were able to print all of their different designs at the same time. They were able to do all their dynamics, select the best, most suitable design, and proceeded with that. That was all done in less than 8 weeks. From the time they started the project till they had a model that they had chosen, had all the specifications for, and were going to production with it. Yeah. Maintenance parts. This is actually where we got involved originally with Aramco, was on maintenance parts and reverse engineering. This is a case study of a company called Altera. They make mud motors for downhole oil and gas. The rotor and stator pieces, they were machining these out of 4145. The situation that occurred was they had a demand that their own production was not able to keep up with. So they contacted us to see if we could help with that demand. We started producing these. In their quality assurance testing, what they discovered was that our properties actually improved the life of the part by a factor of 2 to 3. The part was also 3 times less expensive. This is where I wish I'd have known what they were being charged for that first part. The U.S. Navy had an issue, this was a number of years ago, a submarine had come in for maintenance. During that maintenance, someone lost a motor cover. It was not a very critical piece. However, their safety engineers would not release the sub back to sea. We were contacted, they had the drawings. The OEM had quoted them a 9-month lead time, and they just could not afford to leave the submarine in dock for 9 months. So we received those drawings. It's a very simple design, quite honestly. We took that and did all the CAD work, printed the part, and delivered it in 3 days. We went above and beyond our normal process, but just to demonstrate what can be done. Standard Alloys is one of our large foundry customers, and they do a lot of impellers, a lot of pump housings for the oil and gas industry. They had a requirement to supply a part that was a 57-inch impeller, and they didn't have the tooling. They were actually creating this maintenance part because the original OEM was no longer in business. They did the design work of this and sent it to us, and from the time they got the job from the customer to the time they delivered the finished part was 8 weeks. So the speed at which these technologies are able to help with maintenance parts is incredible, especially if the tooling doesn't exist. Okay. This is kind of one of my favorites because I was actively involved in this. We had gotten contacted, a customer had bought a 1956 Ford and was restoring it, and they could not find an intake manifold. And without the intake manifold, he could not finish rebuilding this car. The gentleman went to Ford and asked for the permission and to have access to the drawings. Ford granted them that. He did the CAD work. We then used our technology to print the cores and the mold, and it was cast. And the only condition that Ford and us put on this customer was we each get one of those castings. So I have one of those castings, and so does a colleague at Ford. So. But again, these were maintenance parts that were not available. Okay. With my work with Aramco, one of the pushes that they kept bringing up was reverse engineering. Okay.
Couple 2 minutes.
Okay. Reverse engineering, you can make a bad part very quickly with these technologies. So you still need to understand the part. We're not about just duplicating geometry. Okay? You need to observe the part, you need to understand it, gather whatever drawings, specifications, etc. We can then reproduce the geometry through CT scanning, laser scanning, etc. We then build the CAD model, repair it, manufacture. This is a bearing housing that we had done for Aramco. They had done the scanning work, and within 4 weeks, we produced a finished casting. Originally, I think they were quoted a 9 to 12 month lead time on this. So for localization, where's the benefits of additive? It's, we enable a very fast product development cycle, multiple iterations. We're able to reduce costs and time due to the lack of tooling. There is no tooling requirements. It's a great application for short production runs. It costs us the same to do 1 versus 50. And then the reverse engineering aspects. So with that, I thank you.
Thank you, Robert. Okay. The next presentation will be from Mr. Takora Shishiyama, the CEO for Taurine membrane, and he will share his experience about localizing this industry in Saudi Arabia. Thank you. Please.
Thank you very much. Okay.
You need help?
Okay.
Please. You need help?
No, it's okay. So here's my
Okay.
what I speak. So good afternoon, gentlemen. Assalamu alaikum. My name is Takuro Shishiyama of Taurine Membrane Middle East. So today, I will introduce. Okay. Oh, thank you very much. Very kind of you. Today, I will introduce our challenge to start manufacturing of high-performance reverse osmosis membrane elements in Saudi Arabia. So Taurine Membrane Middle East, we call TMME, was established in 2014, just born, as a joint venture between Abnel Holding and Taurine. And signing of shareholders agreement was take place on February 19, 2014 in Tokyo in the presence of Saudi Arabia's King Salman bin Abdulaziz Al Saud and Japanese Prime Minister Mr. Shinzo Abe. TMME was established focusing on transferring water treatment membrane technology into the Kingdom of Saudi Arabia. TMME will start manufacturing reverse osmosis membrane element at the Damman Third Industrial City in the middle of 2015. That will come very soon, and start supplying products to 25 countries in the Middle East and North Africa. Activity of TMME is not only limited to the manufacturing. It will cover extensive technical support for valued customers in the region, and research and development of novel membrane technologies by collaboration with leading research institutes in the kingdom. The business of TMME is not only for reverse osmosis membrane, but also covers ultrafiltration membrane, which is used for pretreatment of reverse osmosis, and membrane bioreactor, or MBR module, for wastewater recycling. Population explosion and human industrial activities have been causing huge consumption of water resources and water pollution. Membrane technologies became as one of the most important technology to solve the global water shortage. Especially in the desalination field, RO membranes have been widely applied to not only seawater desalination, but also brackish water desalination and industrial and wastewater reclamation. Middle East was recognized as the most difficult place for reverse osmosis operation. However, by the successful operations even under severe seawater conditions such as high salt concentration and high temperature. It is becoming as a major water resource in the region by its energy efficient characteristic. The structure of RO membrane is shown in this slide. Composite RO membranes are usually composed of 3 layers: functional layers, porous support layers, and fabric substrate. The functional layer is cross-linked aromatic polyamide having 90% or more market shares with excellent water permeation and salt removal performance. The structure of spiral wound type RO membrane element is shown in this slide. The sheet membrane is rolled up as a spiral shape together with feed spacer, which carries feed water, and permeate spacer, which carries permeate or desalinated water to the center tube. Because of very high durability of this element shape, and together with high density of membrane area per volume, this spiral wound shape became a standard design of reverse osmosis element. For seawater desalination application, it requires very high durability against high pressure and high temperature. By the extensive and continuous R&D activities to improve the performance, industry has been introducing the high-performance products every year. This slide shows recent introduction of new seawater reverse osmosis membrane by Tore. By responding to the development of water treatment membrane market and the policy of Tore to go into the market to be closer to the clients, Tore has been opening offices for marketing, sales, and technical services, and together with production facilities. Now, Tore is operating 10 major sales offices and 5 production facilities. However, having multiple production facilities, they are operated as one seamless organization, and all of the facilities have exactly same performance of products and quality. So I will explain about our challenge in starting production in Saudi Arabia. Is shown in this slide. RO membrane is adopting a very high technology. Quality of products shall meet with the global demand and need to apply high production technology. It is a mandatory goal for us that 3 points shall be achieved all together. I will introduce how we will overcome this challenge. Tore already has experience to successfully localize the RO production technology to the United States, China, and Korea. The method applied to other factories and even fine-tuned by the experience in the past will be applied to this TMME factory. First point is production by automated technology. TMME to install machines for automated assembling of reverse osmosis membrane elements, which enable the quality of products to be the same. Second point is 100% performance test of the products for quality assurance by using exactly the same condition and equipment to other factories. Third point is to perform preventive maintenance of facility by the employees. And the last point is to train employees at other Tore factory using the same production equipment. In order to localize the industry, importance of training is no question. Other challenge is to localize material supplies. Every materials of the element will affect to the performance and quality of the products. Therefore, it will be required to perform very careful study to qualify local suppliers, including QA and QC level of the suppliers. As sheet membrane is the key material affecting to the overall performance of RO membrane element, localization of the production of sheet membrane will come after training of employees will reach to the satisfactory level. By taking such steps, manufacturing of high technology of products, localization of products, and localization measure material will sure to be achieved altogether within a few years. Further challenges. So we have the further challenge for localization of industry. TMME will transfer key technology for production, such as production technology, production management, production management technology, technology for production equipment maintenance, technology for QA and QC. And final goal of localization is to train employees to maintain, fine-tune, and establish such technologies, including R&D of new membranes and elements in the Kingdom of Saudi Arabia. In order to achieve this, TMME will continuously invest for the human resources, the most important resource for the kingdom and the company. Through the activities introduced today, TMME will like to contribute to localized membrane technologies, which is the key technology to conserve water, the most important resources. Thank you very much for your attention.
Thank you, Mr. Takura-san, for a nice, good, short, brief presentation to the point. Thank you. Okay, last night there was signing a contract about this new technology, Megaton, and Mr. Masoro Korihara-san, he will share with us more information about what we signed last night and what is this new technology about. Thank you.
Thank you very much, Mr. Chairman. Distinguished guests and all participants, I'll be very happy to be here to present our megaton water system in Japan. Firstly, how do you say that megaton is a 1 million cubic per day CO2 desalination, one plant size. And this research was done by Japanese government funded. The money's volume is $40 million for 4 years project. And now we are collaborating with SWCC. So yesterday, as you know, the signing ceremony was done already. So I used to be the senior scientific director of such a project and also fellow of Torre. And the research scheme is shown like this. Japanese government affords fund to the New Energy and Industrial Technology Development Organization, so-called NEDO. And we organize overall management on R&D on 8 research topics. And in such research topics, 5 is key technology, and 3 is system technology. And the mission of this research is energy saving, low environmental impact, and low cost. And as you know, the CO2 RO plant is growing globally, and the vertical line say the RO plant size, 1 unit, 1 plant size. And you can see from the trend of the large plant since 1970, increasing in the largeness. So at the time of the 2014, as you know, the almost already 500,000 cubic per day plant is now running. So at the time of 2020, we predicted the market customer requires the size of the megaton size plant. So that's why we have to reconsider the technology itself at the time of 2020. And our research project's vision is very quite clear: sustainable desalination and reclamation. And the mission is shown here. 20 to 30% energy reduction is the first mission. Second one is a low environmental impact, less chemical addition. And finally, the most important, water production cost will be half of the conventional one. That's our 3 mission. And the water cycling megaton system is composed of the CO2 RO system and wastewater reclamation system combined. So water recycled like this. And you can see the most important part is how to brine discharge. We use the pressure retarded osmosis to recover the energy from the brine. Then the discharged concentration of CO2 will be the same as the feed CO2, like this system. And this is the output. You can see the CO2, then bio-friendly pre-treatment. This is one characteristic. And then low pressure, multi-stage, high recovery SWRO system. Then municipal water, and also we can use, as I mentioned previously, PRO, pressure retarded osmosis. So from this slide, you can see the membrane, pre-treatment, and the equipment, also systems, infrastructure. This is also same as major megaton water technology. This is the integration of the advanced device and system technology. As a device and materials, we propose a low pressure CO2 RO element, next generation energy recovery device. In addition to this, the next generation high pressure resin pipe instead of the metal. And as a system, we propose a low pressure multi-stage system. We abbreviated LMM system with high recovery, and bacteria friendly RO system and pressure retarded. Today, I just explain 2 points. As a device and material, low pressure CO2 membrane. From the side of system, we introduce a low pressure multi-stage system. From these tables, the vertical line shows rejection, solute barrier layer. And you can see the high pressure desalination and low pressure desalination. From this figure, conventional, now update available membrane is operated over the 6 megapascal generally. So from our project, we are more and more shifted to the lowest pressure side. We call low pressure CO2 RO membrane. Still, this membrane keeps very nice salt barrier over the 99.8% salt reject. That's why our new developed membrane will be operated about 5 megapascal. This is much contributed to the energy saving for a total system. And the second important point is the system improvement, innovation, low pressure multi-stage CO2 RO system. You can see conventional one is a CO2 intake, and as treatment now use ultrafiltration.